I'm hoping to make some cool connections with you here. We had this the other day, the reference angle and the reference triangle notes there. An ordered pair XY along the terminal side of an angle, rotation theta, is located on a circle with radius r such that, well, something's going to happen here. So let's just think first quadrant right now. If I have an ordered pair XY and I actually extend this out, well, that's obviously the radius of the circle. But when I drop this down here, we got to think about how we got to that point. What did we do? We went right x, we went up y. All right, so there's a couple things that I think are neat that happen here, and I want you to understand. Well, first of all, I hope you're seeing the Pythagorean Theorem. X squared plus y squared must be equivalent to r squared, and we will see many renditions of why that's neat moving forward with identities too. But right there, that's true based on this diagram. Now, please know that r is always reported as a positive value because it is the radius of that circle, okay? So I want you to think about this real quick. You know, how do we relate this back to the x coordinate? Well, I just want you to think about this reference angle of theta right now. If I asked you for cosine theta, right now, cosine theta, right here. I would hope you would already have that ratio in your head of adjacent over hypotenuse. You would have x over r, okay? But I want you to think real quick of what if we took this and we actually multiplied by r to both sides of that equation? Well, you can see that, oh, those are going to cancel off on this side, and x is simply equal to whatever cosine theta is times the radius. Well, look at this. So therefore, for any given radius r, the x-coordinate, like that point right there, will literally be equivalent to r times cosine theta. I hope you could follow that. Now, switch colors here. Similarly, if I asked you for sine of theta, you would say, oh, well, that's equal to y over r. And again, if we multiply both sides, you know, by r here, you'll see that the y-coordinate is simply r times sine theta. All right, well, here's the deal. That, if you're like, okay, that's great, neat, Powell, I don't really see any connection, but now I want you to jump to the actual unit circle. Now, I want to take a moment here to reflect on the fact that a lot of people refer to the unit circle when they're not actually using the unit circle. And we use a circle for reference as well. I'm going to go back to the earlier notes here. You know, if you look here, okay, these problems we did, those are not the unit circle. I mean, the concepts that we're talking about with ratios and trigonometry are all the same, but the radius of this circle is 1.3. This radius is 3 root 2. That's not technically the unit circle. So when I talk about the actual unit circle, it means it has a radius equivalent to 1. 1 unit, whatever that is. Now think about this real quick. Therefore, on the unit circle, the x-coordinate, which was right here, r times cosine theta, is literally cosine theta. So this ordered pair will be the value of cosine theta. Sorry, that x value of the ordered pair. And the y-coordinate, if we put a 1 in there, is simply sine theta. Well, here's where this really comes into play. I'm going to show you multiple ways of thinking about this. Okay, I'll show you my favorite, but I'll show you multiple ways because everybody thinks differently. For angles of rotation whose terminal side is on the x-axis, think about what that just said. Okay, not the initial side. Here's the initial side, okay? But what if this was also the terminal side? If I put the terminal side up here, we can drop down and make a reference triangle and life is good and we find ratios. But if I can't do that and there's no triangle available to us, we still need to be able to find, here, terminal side could be over here as well. We still need to find the ratio there. So what does that mean? Well, all it means is that you can literally use the x-coordinate as cosine theta. So here's how I personally like to think about this. I like to think about it all the time as the unit circle because we could go out to 10 units this way. We could go 8 units. We can go 7. But we could always just think about going 1 unit, which is like 1, 0 right there. Okay, well, if I go 1 unit, that's going to give me the same ratio as going out 5 units or 6 units because I'm having the exact same angle there, right? All right, well, what is sine and cosine and tangent of this angle? Well, according to this, we're supposed to, opposite over hypotenuse or y over r. But according to what we just learned right here, this is called a quadrantal. So if I understand this, I know that sine theta right here is literally going to be equal to whatever the y coordinate is. Well, the y coordinate is 0, so I know sine theta is going to come out to 0. That's what's going to happen right there. Okay? Now another way, there's multiple ways to think about it, but just look right here. If r is 1, sine theta is equal to y, right? So sine theta is equal to y. Well, what's over 1? That's the y value right there. Well, what if I was over here? Well, when I'm over here 1 unit, that's going to be -1, 0. So what's sine equal to? 0. Now, why? Because it's just the y coordinate. Now, what about cosine? Cosine theta is equal to, well, over here, it's going to be equal to 1. Over here, it's going to be equal to -1. So it's going to be either 1 or -1 depending on where you're at. This is just the tip of the iceberg. I'm going to go through all these problems with you down here to get you to really understand all of this. All right, for angles of rotation whose terminal side is on the y-axis. So now we're talking about, just to be crystal clear here, we're talking about an angle here, initial side, and then terminal side there or there. Okay, well now we got to be thinking about an ordered pair 0, 1, or down here 0, -1. Again, multiple ways to teach quadrantals. This is just my favorite way, and we'll talk about different ways as we do more problems, but you do need to get comfy with the quadrantals. Okay, so here's the deal. If I was to actually ask you for sine of theta, now I'm just saying theta, but I'm talking it through. Let's say I said pi over 2 up here. That would be 0, 1. Well, the sine value is 1. Why? Because it's equal to the y value. What would cosine of theta be? Again, me speaking out to you that would be pi over 2, I would get 0. So we can get sine equal to 1 or -1 to answer this. When we have that terminal side, north or south, we are going to get a sine value of 1 or -1, but the cosine of theta is always going to be 0 because it's just the x value. Okay, so now I'm going to put this into play here, and I'm just going to show you. These are all quadrantals across here. So I'm going to show you what goes through my mind. I know, scary thought, but let's just do what Powell's thinking when he does this problem. First of all, I have a strong understanding of this. I have a strong understanding of where pi over 2 is. Boom, I know it's north. So immediately I'm thinking about an ordered pair 0, 1. Just so we're all clear, the x value is 0, the y value is 1. So when they ask for sine there, they're literally asking for the y value. I answer it, it's 1. Look how easy that is. Now, next question. Ooh, let's change colors. -3 pi, well, that just means go this way. So 1 pi, 2 pi, 3 pi. All right, I'm ending up right here. What's the ordered pair? -1, 0. Okay, so if the ordered pair is -1, 0, I'm supposed to, oh no! Powell, you only talked about sine and cosine. Well, think about sine. If sine of, I'm not going to write it all out, but just because it's hard with this. But if sine is -1, would we agree sine of -3 pi is -1 right here? Well, we have to take the reciprocal of that. What's the reciprocal of -1? Well, that's -1. Fantastic, we got it. All right, let's do another one. How about -5 pi over 2? Going this way again, wouldn't this trip all the way around be 4 pi over 2? So 1 more pi over 2, I'm going to be right here. Oh, that's the ordered pair 0, -1. Well, I'm asked for cosine. Well, that's just the x value we learned, so 0. Look how fast that can get when you get to be awesome. All right, so here we go, 4 pi. I know that all even pi's are right over here. Again, these are all called quadrantals, so that's at the order pair 1, 0. Okay, well, secant. Well, that's the reciprocal of which one? Cosine. Cosine is 1. The reciprocal would be just 1. Cool, keep it going. Tangent of pi. Well, pi is right here. So -1, 0. Conceptually, oh wait, tangent. Powell, once again, you only told me sine and cosine. Okay, but think about what that is. On a unit circle, here's a connection for you real quick. Okay, on a unit circle, I just said if this is 1, that means the x value is cosine theta and the y value is sine theta. So, hey guys, remember that's not an r there, that's a 1. If we're on the unit circle here, what would tangent always be equivalent to? Opposite over adjacent. Isn't it sine theta over cosine theta? Well, sine's really just the y, cosine's just the x, right? We've made all these connections, hopefully. So when I look here, I got to take the y, divide it by the x. Well, that's 0 over -1, so I'm going to get 0 there. All right, and last one here, cotangent of -7 pi over 2. Well, I'm not going to lie, we were already at -5 pi over 2 here, so there's -6 pi over 2. That would be -7 pi over 2 right up here. So that's going to be 0, 1. Cotangent. Wait a minute. That would be not sine over cosine, but cosine over sine. So that would be x over y. 0 over 1 is 0. Okay? Now, there weren't any right here, but I want you to know, like, look at this. If we were to actually ask you for tangent of this one, that would have been undefined because 1 divided by 0 is undefined. So you're going to get some that are undefined as well. All right, here's some cheaters that you may have been taught in the past. I've never taught these, but I don't want you to, whatever works for you. So sine means if you're at these quadrantals, remember, what's the y value right here? The y value is 0. The y value is 0. The y value is 1. The y value is -1. So that's a cheater that you've seen in the past. Cosine, just think about the x value. What's the x value? 1. What's the x value? -1. What's the x value? 0. What's the x value? 0. Tangent, what's the x value? Oh wait, no, I got to think sine over cosine. So over here, I am having a y value of 0. 0 over anything, y over x is going to be 0. That's going to happen over here as well. But again, like I had just kind of talked about up here, these two are going to be undefined because you'll be putting a 0 in the denominator. All right, so once you have sine, cosine, and tangent, you can get the reciprocal functions as well, or identity, or values as well. All right, keep practicing.